Right, so blame my English teacher for that last phrase. Okay, so what you're looking at here is essentially the questions I mentioned and where you would get them in your homework. There are only 6 questions here, but they take a fair amount of time. So the first one I'm going to do is like question 2. So I put little stars on things when they're like question 2. If you've not done WebAssign before, do you know that the questions are different for everybody? They change the numbers on you. So Mia can't really phone up Teresa, but she should at least for help and say, look, a Zoom meeting with her and say, I'm having trouble, like study partner, and because her question won't be exactly yours, but at least it's the same question, but with different numbers. Right, back to this guy. I'm going to do a function, f of x, and it's, let me find the damn thing. Here we go. I guess I should write down the function the way they have. I'm going to do 2x over x. Oh, what shall I do? X plus 1. Yeah, no, let's just stick up there. I don't want 1. There. And let's suppose we're interested in what's happening at the point 1, 3. Okay, so that's my version of question 2. So you've got this fractional function, and we're interested in the slope of the tangent line at the point 1, 3. And you are being, well, they phrase it in their own way. So let me try and make sense of this. They tell you that q is x, comma, 2x plus 4 over x plus 1. Well, yeah, I guess it is. But what they're just saying is that q is going to be the other point, right? P is this guy. Q is going to be the other point. And then they give you a list of values that you're going to use for x. If I was doing this question, I would simply be just telling you that q is, what number am I doing? Am I doing 1? So, okay, I'll do a 5. And then I'll do a 2. And then I do, getting really close to it, how about a 1.1? Then get really close to it, maybe do that guy. And just for completeness sake, do you know that you can also get really close to a point by coming in from the smaller side? Instead of 0.9 and something like 0.5. Right. So for every single one of those points, they're going to be the new value of q. If you kind of look at what's happening here, can you see that I'm making no attempt to do this accurately? It's just a visual thing. Can you pretend that that's what y looks like? It looks like that. And what we're doing is, look, we're picking a guy over here to be q. And then we're picking a guy here. And then we're picking a guy here and then here. And then we're going the other side of it. So can you see you're kind of homing in round about there to being very close to 1. So what we're hoping to see here is that when we find the slope of the line joining P, which is a fixed point, that's not going to change, to each of these different Qs, what we're hoping to see is a pattern that would allow us to do a guesstimate of the slope of the tangent line. Now, these questions are quite laborious and they involve a lot of calculations. And I am going to do this in 2 different ways. I am going to do it purely just the long way, for want of a better description. So let's do the point Q is 5, comma. Well, I have to figure out what the y coordinate is. So what's that going to be? Oops, let's find out. If you do 2 lots of 5, that's 14 on the top. And if you stick a 5 in the bottom, you get a 6. And the answer is about 2.3 repeater, right? And P is a fixed value of 1.3. And if you're being asked to find the slope joining P to Q, you can use the difference in the Y's, take away the difference in the X's. So it's going to be 2 point, I think they want 6 decimal places. Okay, 1, 2, 3, 4, 5, 6. Take away 3, divided by 5, take away 1. So what's that? Negative 0.6667 over 4. And that is negative 0.66667 divided by 4. And the answer I get is negative 0.166661, 2, 3, 4, 5, and 8, roughly. So there we go. The first answer is negative 0.166668. That's a lot of work, isn't it? And I've only done 1 of 8. So wouldn't it be helpful if we could find some way of speeding this up? So I'm going to show you. The setup is long, but once you've set it up, it does get a lot quicker. So hopefully, I've got a better idea. I'm going to show you an online calculator. Right. Are you looking at a nice big calculator? Right, that's easier than me doing the screen. So I'll switch it on. And first thing you do is you go to Y1 and you type in the function. To remind you, this function is 2x plus 1 over x plus 1. So you go bracket and you go 2x plus 1, close the brackets, and then you do divide, and then you do x plus 1, and you also put a bracket around it. If you do not put the brackets around this guy, it will not be the right function. It might look right to you, but the calculator will. Right, did we somebody late coming in? I get a chat. Let's figure out what's going on. Right, question is, do you estimate the value of Q? If you're talking about that written down one, I just plugged 5 into my calculator and that's the answer I got. So it wasn't so much an estimate as a rounded off value because it went on forever. Right, let's go back to this guy. All right, so that's step 1 if you like. Put this in. And if you like this shortcut, what you need to do, I think, is have a look at the video and, take all these steps slowly. So I'm going to go second quit to get out of there.
And so does Desmos work for this as well?
I don't think so, unfortunately. So I'm going to hit variables.
Professor,
And I'm going, yes.
you entered 2x plus 1. It should be 2x plus 4.
Oh, God, thank you.
Yeah.
That would have screwed up a whole load of answers there. Okay, then get out and, oops, do variables and kick over here and do function and do Y1. Right, now you see that guy? I am going to be doing the value of the function at 5 and at 1. And that means, and I just realized I have to do something first, that it's going to go bracket, variable, Y1, I know this is a bit long-winded, the value of the function at 5, that's basically Y of Q. Then I'm going to take away, and you have to hit a whole load of buttons, and there's probably a shortcut for this. the value at, where was it? At 1. Close brackets, divided by, in this case, it's 5, take away 1. And I made a mistake, but I can fix it. Brackets, 5, take away 1, close brackets. So that's basically XQ, right? Take away XP, and YQ, take away YP. Right? Now, when I hit enter, I better get negative 0 point and all that good stuff. There. Now, you might say that was more work than the way you did it a minute ago. Well, yes and no. Now watch the trick. Second entry. I am now going to go back and I'm going to pick a different one. The next one in my table was 2. So I just go here and I put in a 2. And I go here and I put in a 2. And the rest stays put. And now I hit enter and I've got my second answer. Now, do you see that was a lot quicker than doing the whole thing from scratch again? That particular one is negative 0.12345 Now, it gets a little bit messier for the next one. The next one was a 1.2. Was it not a 1.1? So, second entry. Now, if you go to the 2 and replace it by 1.2, it'll overwrite some of my stuff. So what you have to do is you have to insert it. So blue button, insert, and now you can type in 1.1. And delete that. And here, I don't know, it's probably quicker just going 1.1, take away 1. Right. Okay. Now that will give me the next slope, and it's negative 0.476190. Right. The next one is 1.01. So I'll go here. I'll just insert, hopefully the 0 will go in the right place. It's probably just easier to rewrite the bottom. And now I've got the answer, negative 0.4975. Okay, let's go back to the screen and show you what the working looks like. Right, that was the slope from P to this Q, this one, and finally that one. Now, we look at this, we're looking for patterns. You're just going to have to trust me on this one. And I'm not saying it's exactly right, but if you did this one, you'd get an answer something like that. Can you see a pattern where this is homing in on something? And if you look at the 2 closest numbers, do you see that they're kind of bounding a single value? So if you were a gambling person, based on these 2 values, what would be your best guess for the slope of the tangent line?
Negative 0.5.
Yeah, and expect that the answer should be something reasonable, right? So look for things like, well, that's a half, right? Look for quarters, a half, 3.5s, things that are going to be reasonably nice. It's not likely that they're going to have nothing 0.12778 as the homing in value, right? Because that'd be very hard to even know that that's what was going on, right? So look for obvious rather than being too subtle. Now, I don't know if this shortcut that I've shown you on the calculator was too pernickety for you or not, but don't you have the good old-fashioned, slog it through one at a time? Right. The thing you have to be careful is make sure that if you're doing this on your calculator, that it's the top thing with a bracket divided by the bottom thing with a bracket. If you do not do the bracket, something really nasty will happen. So let me show you it with this one. if I just typed in, oops, 2 point, a lot of threes, take away a 3, divided by 5, take away a 1, you notice that that answer is not the one that's there. If you put a bracket round 2 point, lots of threes, take away a 3, divided by a bracket 5, take away 1, do you see you now get the answer that we'd expect? Now, it's a simple thing, but can you imagine you spent 20 minutes in this and wrote down a whole load of answers, and then, you know, that's 30 minutes of your life you're not getting back. And the only thing you forgot to do was brackets. So be careful about it. When you look at, when I do the y equals, did you notice that I did a bracket round the 2x plus 4 divided by a bracket round the x plus 1? That was for the same reason. Those brackets are important, right? They tell the calculator order of calculation. Now, someone mentioned, does Desmos do that? I don't believe it has that feature, but if it does, great, use it. Any questions about that? It's quite a long question, but
I have a question.
Yes.
So we figured out all those different slopes.
Yes.
Are those all going to be different lines on that around P? Like the line, the tangent is going to be kind of tipped different ways all around that P.
Yeah. So imagine P was here, and the guy that we're really hoping to find is this tangent line, the green line, right?
Mm-hmm.
What we kind of have been doing is we did this guy up here, right? That's like at 5, whatever it is, right? And we used that slope to estimate this one. Do you see it's a little bit out, but it's pretty good?
Mm-hmm.
And then we picked a guy that was there, and that one's a little bit closer, isn't it? You know, as you get closer, as Q gets closer to P, don't the lines joining P to Q start getting darn close to the same sloping line that the tangent line would be?
Mm-hmm.
And that's really kind of the argument for why this process works, is that if you bring Q really close to P. Now, in a practical way, if I wanted to estimate the slope of the tangent line at 1, 3, do I really need to go through this 8-step process of doing it 8 times? Probably not. Wouldn't I just pick a Q that's really, really close to P? You know, maybe a 1.5 zeros and a 1 kind of Q? And shouldn't I only then need to do my calculation perhaps once? And I'd be reasonably comfortable that the estimate, right, because that's all it would be, this thing here, would be darn close to the real answer. And by the way, that is the real answer.
So yeah, we should put more weight on our answer if it's closer to P than any answer that's further away from P.
Yes.
And that's why we don't average them or round them or anything like that. We just go with the one that's closer to the point.
Yeah. So in this case, these two.
Yeah.
And it's helpful to have a value where the x coordinate is a little bit bigger than P's, and another one where it's just a little bit less. And the reason why that's sometimes helpful to do that is that if you kind of average these two numbers out, don't you get this fella? And also it kind of emphasizes in your brain that everything is going well. If I did this one and it was negative point, a whole load of stuff, and I did this one and it was a positive 0.5, then I'd be really worried, because what that could be telling me here is that I might be having a function that has a really weird shape to it. Do you know some functions have shapes that look like that?
Mm-hmm.
By the way, it's called a cusp. I would have a real problem trying to do the tangent line at that point. And that would show up because this and this would not be close to each other. One would be some positive thing and the other would be some negative. And the reason for that would be, if you come in from this side, won't you get a positive slope? But if you come in from a point on this side, won't you get a negative slope? And so you would see that. So technically speaking, it's much safer to pick one number where the x coordinate is a little bit bigger than the p-value, and another coordinate for q where it's just a little bit less. And those two would be the guiding factor for your guesstimate. That makes sense?
Yes, thank you very much.
Okay. Things go slow And that's okay because they always go slow because these things take time. That's essentially how you do that, guy. Right. Any more questions about that before we look at tables of values?
There's one in chat.
Thank you. I can't see the chat, so I'm going to have to find out where the heck it is now. So I have to close my major window. Now I can see my chat. Thank you. Should we get in the habit of checking if the negative or opposite sides to confirm shapes? So should we check in the habit? Okay, should we be in the habit of checking for a negative? Right, when you do this, let's suppose I wanted to find my estimate at 1,3. Now let's pick a different number. At p equals 7,10. You should do a 7.1 and a 6.9 for sure, because you see either side is 7. And find the slope of the tangent, the line joining P to Q in both those cases. And that's a good habit to get into. So if you're an engineer and you're just, I just want to get an idea of what this thing looks like, that would be a way you could do it. Okay, now, the next fella is essentially going to be using tables. I think I've picked the wrong one. Well, let's talk about it first. We're going to use a table of values. And the questions I'm talking about are 1 and 6. I'm going to do my own version of 1. That way I don't need to zoom about. So in this story, we have a big tank with I don't know, with 500 gallons in it. And every 5 minutes, we record how much gallons is left. So there's a hole in it and it's leaking out. At the 5 minute mark, 300. 10 minute mark, there's 100. At the 15 minute mark, it was 50. Then there was 20, and then it was empty. So can you imagine over a 25-minute period, the entire contents, the 500 gallon, has leaked out of this big tank. That's good. We're going to have a fixed point P that we're interested in, and I'm going to choose the point P to be P100. And they give us a table, and they tell us who Q is, and we're being asked to find the slope, which I would call PQ. Now, there isn't any shortcut to these. I apologize for that. I wish there was. This is just good old-fashioned what you do in chemistry labs and physics labs. Don't you just grab a calculator and hit buttons a lot? So that's what we're going to be doing. So we are going to, let's see, what do I want? 110? Yeah. So we're going to do at 0, 500, at 5, 300. We don't do 10. We'll do 15, 50. We'll do 20, 20. And we'll do 25, 0. And for each one of these Qs, there's 5 of them at least in my table, we are going to find the slope from this P to whatever that Q is. So let's pick one. P is going to be that guy. And for my first one, Q is going to be 0, 500. Now you want to find the slope from P to Q. And what that is going to be is YQ, take away YP, over XQ, take away XP. And if you're wondering who these guys are, right, does it make sense? X and Y coordinate of Q, X and Y going to P. What have I got? I got a 500 take away a 100. And I've got a 0 take away a 10. And I believe the answer here is negative 40. And the units are gallons per minute. Now let's pause on what that's telling me. In a physical world, isn't that telling me that in the first 10 minutes, right, from 0 to 10-minute mark, in the first 10 minutes, on average, you're losing about 40 gallons a minute, right? That's like the rate at which it's shooting out the tank, right? So if you stuck some kind of measuring device, it would be saying, hey, 40 gallons a minute on average. Now that doesn't mean it's constant. Wouldn't it be 50 and then getting a little bit less and then getting a little bit less? Well, on average, it's 40. And you stick in the 40. And then you do this one. And this one is, oh, come on, negative 40. Okay. And this one is yikes, I can't do that one we had to. Okay, let's do that one. Then it's going to be 50 take away 10 over, sorry, 50 take away 100 over 5 take away 10. That's negative 50 over 5. It's negative 10. Okay, I can handle that. Next one, that's here. It's going to be negative 80. Let's see what that looks like. 20 take away 100. And it's going to be 10 take away 20. Negative 8, okay. And last but not least, it's going to be 0 take away 100. 25 take away 10. Negative 100 divided by negative 15. Negative 100 divided by negative 15. It's about negative 6.7. Okay. From this table, here is a kind of summary of the rates at which the liquid is coming out. At the beginning, it's coming out about 40 gallons on average. And then it starts slowing down. And then
Did you make a
slowing down.
mistake on the second one when you have 50 minus 100 and then 5 minus 10 and you don't have a minus 5? So minus 50
Oh.
over minus 5 or what?
Okay, what I may have, I'm doing these too quick for my own good. So let me
Yeah,
try this one again.
Oh, the
So
second one.
it's-
Yeah, that one.
So the second one, so it should have been 300, right? 300 take away 100 over 5 take away 10. So what's that? 200 over negative 5, which is negative 40.
It's the one you did, the next one down you did.
This
You
one?
did- Yeah, 50 minus 100,
Okay.
and then you have 5 minus 10, and you don't have a minus sign with that
Oh.
5. So
Yeah,
there's
because
a
that should have
mistake
been
there.
10
10 minus 5.
minus 5. That's what happened. Right. Yeah, I've probably done that same mistake here as well. I mean, the answer's correct. I just wrote it down now.
Yeah.
Yeah, so we got those guys. Okay, can you see that what is happening here is at the beginning, the rate is quite big and then it starts drifting off. That kind of makes sense. I mean, can you imagine that you had a tank and there was a hole in it and it was gushing out? Wouldn't it be gushing out at quite a high rate at the beginning? Because a lot of liquid, a lot of pressure, you know, zooming out, you know? A full can of Pepsi makes a right mess in the first couple of seconds, but doesn't it kind of peter out towards the end? because at the beginning there's a lot of stuff in there, and then towards the end there's not. So how are we going to use this to finish off the question, which says, use this table, and it talks about using two adjacent secants. A secant line are these lines where if you've got a curve, or in this case, we only have table of values, the line joining one point in a curve to another, this line is called a secant. So that's all. That's the name we're given to these. So two adjacent values. The closest guy to 10 is this guy and this guy, right? This guy's to the left of it, this guy's to the right of it. And we are going to try and use these guys by averaging them out. One of them is -40. On the other side, it's -10. So somewhere between here and here would be the 10-minute mark. And if you can imagine being here at the 10-minute mark and you had a gizmo that was measuring it, what rate would the water be coming out at? Well, at this point, it's coming out at 40, right, -40. And at this rate, it's -10. Would it be reasonable that your best guess would be the average of these two? And so that's the number I've got. How reliable do you think this technique is for estimating that particular guy? Do you think I'd be really comfortable with this number, or should I be a little bit skeptical?
Little bit skeptical,
Yeah.
just because they're farther away.
Yeah, there's not an awful lot of information in the table. Isn't there an awful lot more information in the function? Can I get as close to P as I like with the function? But with a table, can I only use the data that I'm given? So I guess the moral of that story is that if you want to get good information from a table, shouldn't you take lots of measurements? Have a lot of numbers in it. So that is essentially what question 1 looks like. And now we're moving on to our last thing, average and instantaneous velocity. Question? Are we good? Right, okay. Let's do a version of question 3. Let's have right. If you didn't know this, neither did I, because I'm sure it's a made-up question, but if you take a rock and you throw it on Mars and you throw it in the air, it goes like that. And if you measure time against y is basically the height, they're calling it y. Can you imagine it might take that parabola shape, right? Just like throwing a rock on Earth. And y, the height, is given by 4t, take away 1.86 t squared. And we are going to find what is called the average velocity. And when you get average velocity, you're going to be given a start value and a finish value. So we're going to find the average velocity between the 1 and 2 second mark. So can you imagine that might be the 1 second mark, this is the 2 second mark. And we're trying to find the average velocity of this moving object. Now I can imagine that at the start, won't it be going up really fast? But won't gravity start slowing it down? And then, in fact, you should be able to tell me, anybody who's done physics, what will be the velocity of that rock when it reaches this point in its journey?
0.
0. When you throw a rock from the ground upwards, doesn't it start off at maybe 10 meters a second, 8 meters, 4, 2? Theoretically, isn't there instantaneous point in time where it's reached the highest point and it's stationary for a microsecond, and then it comes back down again. Right? So this kind of does make sense. That's what I would expect a rock to do on the Earth and to do on Mars. So how do you find the average velocity? Well, it's a change in position, delta position, divided, whoops, I should do it that way around. That will juice thing. Position and delta time. So I am going to find the position at 2, take away the position at 1, divided by 2, take away 1. Does that look familiar to you? Does that look like we might be able to use that shortcut trick that we did on our calculator? Because you're going to have to do about 6 of these darn things. And wouldn't it be better if I could do 6 of these in a quicker way? So I'm going to do, again, I'm going to do it 2 ways. Let's do it the old-fashioned way, right? Just evaluate it. And then we'll use the calculator and see if it makes it life easier. Well, if you're going to do y of 2, don't you have to evaluate this at 2? So you're just going to have to trust me and hopefully I don't screw up, which I have been known to do. So it's going to be 4 times 2, take away 1.86 times 2 squared. So that is 0.56. Take away the value of that at 1, which is what, 4, take away 1.86. So take away 2.14 divided by 1. And so I've got 0.56, subtract 2.14, divided by 1. And the answer I'm getting is negative 1.58. Why am I worried about that?
When you had oh, never mind. Answer my own question.
I wish I could answer. I don't like the fact it's negative. That's what's worrying me. Well, it must be perspective. Right, it is my number. We'll find out in a minute when I do it the other way. Y equals, I'm going to have to call it 4x, take away 1.86 x squared. Oh, I think I know what happened. I know what happened. This number here, I changed it to be 4t. The example that I've got in the book is 8t. That's what happened. It's just, I randomly picked a number that was weird. Did you know that on Mars, when you throw objects up, they go under the ground first before they come up? No, they don't, but they do according to this formula. Right, that's why. If you make this number big, it will look like that and it will have a nice shape to it. So the process is cool. So, okay, so I typed that guy in, I got him, right? Second quit. So I'm going to put this fella in now. So here it goes. I'm going to go bracket, variable. The first one, that's y1. Put in the number 2, take away variable, put in the number 1, divided by 2, take away 1. There we go, right? You see it matches up. Now that I've set that up, can't I do the average velocity from 1, say, to 1.5? Okay, so I'll go second entry, and I'll do insert 1.5. Do 1.5, take away 1, and I'll get the answer negative 0.65. And then can't I do from 1 to 1.1 and 1 to 1.01? And can't I keep doing that? Actually, I could do 1 to 1.001. And these are all average velocities. Now, I'm not going to do that one and that one, but let's do this one. Wouldn't the average velocity from 1 to 1.001, wouldn't that average velocity be very close to what's called the instantaneous velocity, right? Because between 1 and 1.001 second, isn't there almost no time difference at all? So when they ask you at the end to give an estimate for the instantaneous velocity, shouldn't you just use the last interval, right? The one that's closest to 1, which is this case. So let me put this guy in and hopefully it will come out nice. So it's going to be 1 point, insert 001. 001, take away 1. And the answer we got is 0.27814. Very interesting. I have no idea what happens here and here, but provided I did that correctly, which I have, that average velocity is our best estimate of the instantaneous velocity. So for the few moments that we've got left, let me show you what that looks like on the homework. Right, so hopefully you're looking at question 3. Yeah. See, I nod, I'm good. Nope.
Can't see it. No.
Right, that's why I ask. Let's try this again. Come
Sorry,
on,
I had
screen
it pulled
2.
up on my screen, so I just immediately answered yes.
So is it a yes now? Can you see it? You can't see question 3.
No,
What
it's
an-
just black for me, anyways.
If it's black for you, it'll be black for everybody. Okay. It shouldn't be that hard. I should just be clicking on it and it's okay. Somebody up here is just being a pain in the butt. Is this where you say we're having technical difficulties? Yeah, that's it. Right. There is one last thing I need to check. Huh? That's fine. There is no reason except it just wants to be awkward. I'll do this version. Can you see it now?
Yes, it's, I can see it now.
What the
There
heck?
it is.
Who knows what I did wrong? I'll probably never be able to duplicate that. You know when you go to the garage and you tell them there's funny little squeaking sound when you go around corners and the guy says, okay, let's see it, and you take him out and he's sitting beside you and you go around 20 corners and not one squeaky sound happens. And then you drop him off and then as you leave the garage, you go around the first corner and guess what? The squeaky sound's back. Yeah, it's like that, right? I don't know what I did wrong, but evidently I screwed up. Right. Here's this is talking about the graphing calculator, which we've been using. Did you notice that they made that 4t? They made that 8t. That's why my numbers were coming out weird, right? That's why I was getting, you threw it up in the air if it was coming down the way, right? I bet you with this one, it will be going up the way, right? You'll get numbers that work. There's the average values, you see them, right? So let's just pretend that in this question, that's the answer that you got for the last one, right? Then wouldn't we do it's probably that. And that's what I'd expect to see. Now, these numbers here, I have no idea what they are, so I'm making them up. So I'll make it make it get there closer. Yeah, maybe something like that would happen. Do you see there's a distinct, it's homing in on a number kind of pattern? And when you're doing average and instantaneous, the only real guy that matters is this one, isn't it? Because he's the closest to one. But there should be some, at least general trend toward this number. In this one here, there is no shortcuts, but won't you do essentially the same kind of thing? Right? You'll do the average value from 2 to 4, the average value from 3 to 4, the average value from 4 to 5, and then the average value from 4 to 6. You get the answers here. And it says plot the points in the table to create a graph of S as a function, and then figure out 3. Well, I don't know if graphing is help. Can we pretend that from 3 to 4 the answer is 10, and that from 4 to 5 it was 12? Right, something like that. Try to think of a good choice here. Well, I'm interested in 3, aren't I? 3 to 4. 8. I don't know. Try to think of the best way to do this. I guess you could plot them and just see if there's an idea of what you think the answer at 3 is going to be like. I would probably be picking that one because at least it's got 3 in it. It's not a very clear question to me. This one is watch a video, so it's pretty self-evident. Watch the video and do what they tell you. Watch a video and do what they tell you, right? And say hi, everybody, because it's now time up. I'll hang about for a few minutes if you have any questions. And I'll see you tomorrow.
Thank you.
Thank you.
You're welcome. Bye-bye, guys.
Thank you.
Have a good one.
I'll try.
Thank you.
Thank you.
Thank you. Have a good day.
You too, Cassandra. And who else we
I
got?
had,
Margaret.
it's-
Bye-bye, Margaret.
Thank you.
You're welcome.